Today we are going to be using the graphing calculator to do some investigating into absolute value graphs. But before we start using the graphing calculator, we want to make sure that we know exactly what the original, most basic equation looks like. So as it says here, we are going to complete the table below for the equation y equals the absolute value of x. Now, if you remember, when we used to fill in old XY tables, we would always take each one of the x values and place it where x is. So this first one would look like the absolute value of -3. Well, if you remember, absolute value is the distance that number is from 0. So how far away is -3 from 0? Well, it's 3 units. Now we're going to look at the absolute value of -2. How far is -2 from 0? It's 2 units. The absolute value of -1, well, how many units from 0 is that? It's 1 unit. So pause the video, take a moment, and finish filling in this table. Okay, so if you did these correctly, the answer for 0 should have been 0. The answer for 1 should have been 1. 2 should have been 2, and 3 should have been 3. So now we are going to graph these points. So we have -3, +3. So we're going to go, if you remember, this is the x-axis and the y-axis. We're going to go to the left 3 and up 3. 1, 2, 3 to the left, 1, 2, 3 up. Go ahead and pause the video and finish graphing the other 6 points. And let's see what shape you think your graph looks like. Okay, so you should have gone left 2 and up 2. 1, 2, 1, 2. You should have gone left 1 and up 1. Left 1, up 1. 0, 0 is simply directly in the middle. Right 1, up 1. Right 1, up 1. Right 2, up 2, right 2, up 2, and finally right 3 and up 3. So right 3 and up 3. So I pose a question to you here. What does the graph actually look like? Well, if you're looking at this, it should be very obvious what shape it takes on. It looks like a V. Now, there are some important things to know about this V. It is a V, which means it has a point at the bottom. So when you are taking your ruler and your pencil and you're connecting these points from the center, we are going to connect, whoa, that's really thick, hang on. Let's try that again. From the center, we're going to connect. Now notice, I'm not going to stop here. I'm going to keep going this direction. Now, I did not keep going on the other one, just on that first one. We are going to then go back to the center, and I'm going to connect and go out this direction. And so when I am finished, as you can see, I have a very nice looking V. It has straight lines, so yes, you need to use your ID. It has a point here at the center. It should not be curved. It should be a dead point in the middle. And a couple of words that might help you. This point right here in the center, we call that the vertex. So if you ever hear me use the word vertex, I'm talking about that dead center dot. So go ahead and turn the page so we can look at what we are going to be doing on this little investigation. So you don't have a partner, you have me. You're going to be using a graphing calculator to try and discover what happens when we add additional numbers to the graph. But in order to be able to compare these new equations, we need to have the old equation. So we have some instructions here that explain to us how to graph the equation we just looked at. So to graph y equals the absolute value of x using a graphing calculator, we're going to first press y equals. So I have a calculator here that we're going to work with. The y equals button is right there. it brings up a list of equations. Now mine are color-coded because I have it set up special because I want you to be able to see different colors. The next step, we're going to enter in the equation by pressing the math button, arrow right once, and then we should see ABS. That stands for absolute value. So math is right here, math, arrow right once, and sure enough, there is ABS. To insert that, we simply press enter. As you can see, we now have absolute value bars. In those absolute value bars, we're going to press the X button, and then, so there's our X button, it's right here. We can get out, if you ever need to get out of those bars, notice this arrow right here is pointing to the right. We're going to press the right arrow, and we are outside of the bars. To graph it, as our instructions say, we're going to press, there we go, we're going to press the button zoom. That's so that everybody sees the same picture to start with, and then we want the number 6. So if we press zoom, which is here in the top middle, option 6 is just a standard window. It's so that everybody is seeing the same picture. And so, sure enough, there is the graph that we just finished making on the front page. A nice, pretty V. Now this is going to stay black. Every other equation we add is going to be a different color. So just remember, our original picture will always be black. So now we're going to use these instructions here, and we're going to start adding one at a time 4 new equations. Every time I would like you to write down any changes that you see from the first equation to the second equation. Remember, you're always comparing it to the black one. So we're going to put in y equals the absolute value of x plus 2. So we're going to press y equals, which will take us back to our equations. We're going to go down to the second equation, and we're going to go to the same numbers. Math, write 1, press enter, and put in x plus 2. So I'm going to go back to y equals. I'm going to go down. I'm going to press math, arrow right 1. There's that ABS again. So press enter. Now in the bars I want x, but I also want plus 2. And now all you have to do every single time at this point is press graph. So here's our new equation. Do they look similar? Absolutely. Pause the video and write down in words how you would compare this black one to the red one. Try and be as specific as possible. Okay, so we're going to wait and discuss all 4 of them at the end. So what we're going to do now is we're going to put in the next equation in the next open spot. So we're doing the absolute value of x plus 5. So y equals, now I want to go down to my third blank. I'm going to press math, go over 1, there's ABS, press enter, and I want x plus 5. Now remember, you're comparing this blue one to the original black one. Press graph. There's our new one. So again, pause the video for a moment. Write down the difference between the black one and the blue one. Okay, so let's take a look at our third one. Absolute value, this time x minus 3. So y equals, now we need a new blank. So math, arrow right 1, absolute value, x minus 3. Press graph. So again, pause the video, compare black with purple, pink, whatever you want to call that color. Okay, we have one more equation to add, and that final equation is y equals absolute value x minus 4. So to put in this final equation, we go back to y equals. We go down to the fifth equation. We go to math, over, so we see our absolute value, and then we want x minus 4. And so this graph in green, as you can see, is right there. So again, pause the video and write down what you see as the difference between the black equation and the green equation, and then we're going to look at all four, what you wrote down. Okay, so from this black equation to all of these, if you notice, the shape didn't change at all. All that happened was things were moved. So the black one to the original red one. If you notice, all we did was take the black one and move it 1, 2 to the left. So you should have written down in this first block, left 2. The blue one was the next one we did. So again, all we did was we shifted the graph 1, 2, 3, 4, 5 to the left. So we're going to write down left 5. The next one was the pinkish purpley color. This time we didn't go left. We went right 1, 2, 3. And so you should have written down in that box, right 3. And then the final graph was that green one. So from the black, we went 1, 2, 3, 4 to the right. So hopefully you agreed with all of those very easy changes. So I'm going to scroll down to the bottom half of the page. As you can see, the instructions say we're going to go back to y equals. We're going to delete the 4 pretty colored ones, but we do want to keep that original black one. And so now we're going to go through and we're going to add 4 new equations. So let me go back and get rid of all those other ones. So I'm going to go down to each line and simply press clear. Notice I left the original black one there. And then I'm going to go back up here. So if we look at our instructions, we're going to still press math. We're going to go to the right and we're going to go enter to put in absolute value. Here's some things that I want to point out. When we put in the x, look at where this is located. It is not inside of the absolute value bars. So you need to arrow, we don't have parentheses to close, you need to arrow right before you press +3. So let's take a look at what this would look like. There we go. So we're going to press math. We're going to go over. We want absolute value. The only thing we want inside the bars is the x. So we're going to arrow right to get outside of the bars. Now we can press +3. Let's press graph. Remember, you're comparing black with red. There's the original black one. It's going to remake it for you. And here's our new red one. Okay, so pause the video, write down what change you see. Okay, so let's look at our next equation. We are looking at absolute value of x +6 outside the bars. Go back to y equals. New equation. Math, arrow right, there's your absolute value. Put in your x. Arrow over +6. So we're going to press graph and let's see what happens. Okay, so pause the video and write down what change you see this time. Okay, so let's look at the next one. Y equals absolute value of x -1 outside of the bars. Go to y equals. Go down to the 4th equation, math, over right 1, enter, x goes in the bars, arrow right, -1 goes outside the bars, and press graph. Okay, so again, pause the video, Write down any changes that you see. And our final equation is absolute value of x minus 2 outside the bars. Go back to y equals. Go down to our fifth blank. Math, arrow right 1, hit enter, put in x, arrow to the right, minus 2. Press graph. And go ahead and pause the video and write down that fourth change that you see. So let's see what you came up with. Our first graph, again, the original was black. From black, we went to red. Well, if you notice on all of these, again, the shape doesn't change. They all run parallel to each other. So the only difference is we took the black one and we went up 1, 2, 3 boxes. So you should have had in this first blank, you moved up 3. Now we're looking at the blue one. Starting at the black one, we went up 1, 2, 3, 4, 5, 6. So you should have written down up 6. Now we switched over to the pinkish colored one. So we didn't go up this time. We went down 1 box. So you should have written down 1. And then finally, starting at that black one, again, this time we went down 1, 2 is how many boxes we moved down. Okay, so we are going to, we have one more set of equations to look at. So if you will go ahead and turn the page. It tells us again to go back to y equals and delete those other 4 equations. Remember, we're keeping the black one. And now we're going to add several more equations, and if you notice, the numbers are in front of the absolute value bars this time. So let's go back over to our graph, back to y equals, keep the first one. We're going to clear out each one of these. Okay. So let's go back up to y2 because that's where we're going to put in our first equation. So it says, in the equation, you're going to put in the 2 before you press the math button. So 2 and then math, arrow to the right to get absolute, press enter, and put in x. So we're putting these whole numbers and fractions in first. So 2. Then math, arrow right, there's your absolute, and then x. So again, we're comparing black and red. So there's our original black. And here's our new red. So for the first time, there's something definitely different looking here. Okay, and I'll kind of give you a couple of hints. Notice the vertex this time didn't move. And they're both still there at 0, 0. So something else is changing this time. Okay, it's not a left and a right. It's not an up and a down. There's something different going on here. So we're going to look at the next one, and then we're going to talk a little bit. So our next equation was y equals 3 in front of the absolute value of x. Let's go to y equals, go down to this one, 3, math, go over to absolute value, and there's my x. Press graph. And if you notice, that blue one's even a little more different. So what's going on these? What's changed? Because we didn't move anything left or right or up or down. What happened? Well, it looks like we kind of took this black line and moved it in. And then it looks like we moved it in even more to get to the blue one. Okay, maybe some of the words that you thought about were it's thinner or it's skinnier, perhaps. So perhaps in these boxes you wrote down thinner or skinnier. Or maybe you even use the phrase that they moved in. But there is something more that we're going to talk about. So both of these kind of were similar. We're going to talk about something a little more specific, but we're going to keep looking at some equations first. This next one has 1/2 in front of the absolute value. So we're going to come over here, y equals, go down to my fourth equation. You do not need to use a decimal, just do 1 divided by 2. Then math, absolute, enter, here's my x. Well, look at that pink one compared to the black one, even compared to the red or the blue ones. That pink one's definitely different looking. I have another one I want to put in, then we'll talk. Now we have 2/3 in front of our x. So y equals, and go down to the fourth block. So we're going to put in 2/3, math, arrow right, absolute value, x. So what do we see going on here? Well, you should notice again, here's the black one. We used words like thinner and skinnier when we talked about the blue and the red one. But these aren't thinner and they aren't skinnier. It looks like we took this black line and went out with it, or down, whichever word you want. So if you're thinking about the kinds of words that maybe we talked about before, the thinner and the skinnier, what's kind of the opposite of those? Okay, maybe you're thinking of words like fatter or wider. So perhaps you want to put the words fatter or wider in here. Perhaps you thought, well, it moved out more. So on both of these, that's a true statement. But again, there's a better word that we're going to talk about in just a couple minutes. Now, look at these next four. What's one big difference that you see on these next four compared to the first four? Hopefully you're thinking to yourself that negative. So our focus on these next four are going to be what is that negative doing to the graph. So let's go back. Now we're going to put in a -2 in front of the absolute value of x. So I'm going to go to y equals. I'm going to come down to my next blank. Now be careful. Do not press the minus button. Press -2, then math, absolute value, and then x. And there is your next graph. What is the most obvious difference you notice? Okay, write that down. Let's look at the next one. We're looking at a -4. So y equals, come down to that next blank, -4, math, arrow over, hit enter, put in x. So tell me some things you notice. Okay, think about, first of all, was it the skinnier and thinner, or was it the wider and fatter? Okay, well, hopefully you're thinking, well, these are definitely the skinnier ones again. But what was that other difference? Hopefully you wrote down something like it flipped down, or it opened down, or it flipped over. Okay, so these two were definitely back to the skinnier look. But more importantly, they flipped down. That was a big thing you were supposed to notice about these two. So what do you think you can tell me about these two? Without even looking at the graph. Pause the video, write down something like thinner and skinnier, or fatter and wider. And then what else should you write down? So one thing you should have definitely written down, because of those negatives, it was definitely flipped down. But if you look at the numbers, these are fractions again. Well, where else did we see fractions? Here and here. So you should have written down that they were fatter or wider. Now, what concept have we learned about that makes things go up or go down, that makes them go, maybe higher or lower? What is a word that we've talked about before that applies to these kinds of concepts? Okay, think about the other equations we've graphed. What did we always call the number that was in front of the x? Hopefully you're thinking, wait a minute, that number that was always right before x was the slope. Okay, and if you weren't thinking that, hopefully you are now. All of these are referring to the slope of the v. When the numbers are bigger, the slope was bigger, which means it was a steeper line. When the slopes were smaller, that meant that the slope didn't go up as fast. It went up slower. Okay, the rise was slower than the run. So now we're going to scroll down to the bottom of the page. This is the important info right here. We're going to now organize our findings in the boxes. Okay, and if you notice, each box points to a letter. And that letter was one of the boxes that we filled in. So this first letter is the letter in front. That's the box we just finished. So the one big thing we just mentioned is that A behaves like the slope of the graph. On the ones where A was positive, what did the graph do? Well, on these 4 that were positive, if you remember, that was these guys up here at the top. They all opened what direction? Well, hopefully you're thinking they all opened up. What about the ones that had the negatives? Those were these last few. The one big thing we talked about with the negative was it made them flip down, or it opened down. Okay, so this next letter, this H, which box was that? Well, you're going to have to go back a page, so we're going to flip back here. H is inside the bars. That would be these 4. Well, what did you notice? What was the word that we consistently wrote down? We either wrote down left or right. So we're going to go over to that box, and we're going to fill in. H moves the graph left or right. Well, now we're going to get specific. When H was positive, the graph moved what direction? When H is negative, the graph moved what direction? Well, let's go back and look at our notes. Here's a positive, here's a positive. What word did we write down on both of those? Left. Here is a negative, here is a negative. What word did we write down on both of those? Right. So we're going to go and fill that in the box. So when it was positive, it went left. When it was negative, it went right. So you notice that's a little backwards of what we would think. Positive is actually left, negative is actually right. Now the other letter was K. That was the guy after the bars. Well, that's obviously the only box we have left, which is here at the bottom. So what was the words that we wrote down consistently? We wrote down up and down. So we're going to go and fill in those blanks. So K moved the graph up or down. But now we want to get specific. What about the positives and what about the negatives? So go back a page again. Here was a positive and here was a positive. And both times we wrote down up. Here was a negative, here was a negative. Both times we wrote down. So when the graph is positive, or when K is positive, the graph went up. When K is negative, the graph went down. These three boxes are now going to be your best friend. These are the rules that we are going to use now, because now we're putting the calculators away. And we are going to do everything based upon these three boxes. So let's look at some examples. So we're being asked to make a graph given these equations. So I kind of give you some step-by-step instructions here. I want us to decide, do we go left or right and how many boxes? Do we go up or down and how many boxes? So which number went left or right? Well, if you need to refer back, okay, to your rules, we're just going to look this one time. Left and right was this number. Okay, and if that number was positive, it went left. If that number was negative, it went right. We're thinking opposites. So here is that first number. Well, it is negative. Negative means that we go opposite, so we're going to go right 1 unit. Okay, so now we need to know which number moved it up or down. Well, let's refer back once. Up and down was the number at the end. Positive went up, negative went down. So this is positive 1, which means positive goes up 1 unit. Well, the other thing was A. Now, where was A again? A was here in the front. It is the slope. When you think of slope, you should always think rise over run, which means you need a fraction. So let's look at our A value. Well, our A value is -2. But we need a fraction, so we're going to make it -2 over 1. So, to make these graphs, the first thing you graph is the vertex. The second thing you use is the slope. So we're going to use these two instructions to make the vertex. We're going to go right 1 and up 1. So from 0, 0, right 1 and up 1. There's my first dot. Now we're going to use the slope. Well, our slope is -2 over 1. Well, you should be thinking -2 means down 2 and over 1. And you can do it again if you want. Down 2 and over 1. But here's the problem. Right now, that's only making a straight line. And we know these need to be V's. So here's how you get your V. Okay, it's negative. It should be opening down. I'm going to go back to my vertex. And I'm still going to go down because that's the way I'm supposed to go. But I'm going to go to the left 1. And I'm going to go down 2 and to the left 1. That is how you get a V shape. And so from the vertex, we're going to go straight this way with an arrow. And from the vertex, we're going to go that way with an arrow. And there is your first V. So now we're going to do this next one using the exact same rules. So the first thing we need to look at is the left or right number. That's the inside guy. Positive, we think opposite, left 3. Now we need the up or down guy. That's this guy. Negative, we go down. 2 units. Well, what is the slope? Well, where was the slope over here? It was in front. Well, what happens when there's nothing in front? Do you not have a slope? Hopefully you're thinking there's always an imaginary number. This is an imaginary 1 right there. So our slope is 1, but we needed a fraction, so we're going to put it over 1. So we do our vertex first. Left 3, down 2. Left 1, 2, 3, down 2. This time our slope is a positive 1 over 1. So we're going to go up 1 and right 1. Up 1, right 1, up 1, right 1. But remember, we need 2 sides to our V. Go back to the vertex. Up 1 again, left 1. Up 1, left 1. And then draw your nice, pretty V with straight lines and a nice point at the bottom. So what I would like you now to do is pause the video and try these two on your own. Okay, so this one, based on the -2, you should have gone right 2. There is no number over here. That means that there is 0 to move. That is okay. Your slope is already 3 over 4. So I'm going to go right 2, 1, 2. I'm going to stay there. Then I'm going to go up 3 and right 4. Rise 1, 2, 3, 1, 2, 3. There's 4. I can do it again if I want. 1, 2, 3, 1, 2, 3. There's 4. Go back to my vertex. I still go up 3, but this time I go left. 1, 2, 3, 4. I can still go up 3, but I go left. 1, 2, 3, 4. And so that should have been the V that you should have created. So let's see how you did on this one. Left and right, there's nothing inside the bars. If there's nothing there, again, it's a 0. This number right here tells us, since it's positive, we go up 4 units. Our slope is -1 over 3. So 0 left and right, simply go up 4. 1, 2, 3, 4. There's my vertex. Down 1, right 3. Down 1, 1, 2, 3 to the right. Down 1, 1, 2, 3 to the right. But I need my other side. Go back here. Go down 1, 1, 2, 3 to the left. Down 1, 1, 2, 3 to the left. There is my nice, big, fat V. Okay, so turn the page because now we're going to go the opposite direction. This time I'm giving you the graph. You're going to answer the same kinds of questions. Fill in the blanks. So let's look at this graph. We need to decide, did it go left or right? Well, remember, that's 0, 0. So it obviously went to the left, but we need to know how many. 1, 2, 3, that's left 4. Did it go up or down? Well, it obviously went up, and it went up 1, 2. So now we just got to play fill in the blank. Where does the left or right number go? Well, that's the inside. But, super important, remember that left or right is always opposite. So left 4, you should really be thinking instead of a negative, it should be a positive 4. Up or down, we keep it the same. That's a positive 2 because it's up. Pause the video and try the next one. Okay, so let's see how you did. You should have said it went to the right 3 units and it went down 5 units. Okay, so the first blank is left or right. Got to be thinking opposite. So instead of positive 3, we need to think negative 3. Down, we keep it exactly how we think. Down is -5. So hopefully you had those two blanks correct. So let's take a look at the next two, because the next two we're adding in the third piece, the rise over the run. So this first graph, did I go left or right from 0, 0? The answer is no. That's a nothing. Did I go up or did I go down? Well, it obviously went down, and I can count. That's 1, 2, 3, 4, 5, 6, down 7 boxes. Now the slope can be tricky. So here's what you need to know. We always start at the vertex. You're looking for a solid point that crosses at 2 whole numbers. Well, that's not 2 whole numbers. Neither is that, but there is a perfect cross. We are counting from this dot to this dot. So the first question, how much do I need to rise? Well, I am rising up 1. How much do I need to run? I need to run 1, 2, 3, 4. So where does this new piece go in the equation? Well, if you remember, it goes in the front. So in that first blank, I'm going to make a fraction 1/4. Inside the bars with the x is my left or right. Well, there's nothing to put there. You can either leave that blank empty, or you can just simply write +0. Up to you. This last blank is your up and down. Well, down is negative, and we got a 7. So pause the video, try this last one on your own. So first question, did we go left or right? We went left. How many boxes? 1, 2. Did we go up or down? We went up. How many boxes? 1, 2, 3, 4. Now, for our slope, remember we started our vertex. We're looking for a whole number. Well, that dot right there is not whole numbers, but that dot is. There's our next dot we're counting to. So we have to rise, but instead of rising up, we're rising down. So we're going to go down 2, which means it's -2, and we are running 1 to the right. So our first blank is -2/1. Our left and right, since we're going left, normally it's -2, but we think the opposite, so it's +2, and then we go up 4, which is also a +4. So we have one more page, and this is an application of what we just did. So it says here, for the graph below, let f of x represent the original. So this is the, like where we're starting. And g of x represent the translated function. So this is where we are ending. And all we're going to do is simply talk about the left and right and up and down. So as it says here, the graph of g of x is shifted from f of x. So we went from here to here. I am going to pick one point to compare. I'm going to use this dot right here, and I'm going to compare it to that dot right there. So if I start here, I have to go to the right. 1, 2, 3, 4, 5, 6, 7, 8 spots. That's why I wrote down right 8. Then I have to go up 1, 2, 3, 4, 5, 6 spots. So the difference is we play fill in the blank, but we don't use y's and absolute value bars because these are not absolute values. We say that g of x, which is where we end, is f of x, and we got 2 blanks to fill in. We have an inside blank and an outside blank. The inside was the right amount, right 8, we think opposite is -8. Up 6, we think keep it the same, it went +6. So we're going to do the exact same thing on our two examples. So this is our start, and this is our end. So pick a point. I'm going to pick this corner right here, which means I'm going to compare it to that corner right there. Am I going left or right? I'm obviously going left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 boxes. Did I go up or down? Well, I went up, so I need to go up 1, 2, 3, 4, 5 boxes. Now notice I have fill in the blanks. I have the g of x, I have the f of x. I need to put one number here and one number there. Well, this is the left or right. Left 14, we think opposite, so we think positive 14. Up 5, we think positive 5. So you guys are going to try this very last example. Remember, you're starting here, you are ending here. Pause the video and try this last problem. So let's see how you did. Pick a corner. I'm going to pick this corner. So I'm comparing it to that corner. Did I go left or right? I didn't. That's a 0. Did I go up or down? I went down 1, 2, 3, 4, 5, 6 boxes. So for this inside number, since I didn't move, I can either leave it blank or I can put plus 0. For this other blank, since I went down 6, it is minus 6. And that is the end of today's lesson.